Hello everyone, in this video I'm going to be showing you the changes I've made to the Blender Game Engine Python API. I've done two main things. Firstly, I've added collision callbacks, so you can actually access the collisions that a game object is currently experiencing from Python without ever creating a sensor. The way in which this works, for those of you who understand any of the BGE C++ source, is that there's an existing touch event manager, and that registers with touch sensors to dispatch the callbacks, and all I do is I have made a slight change which may make it slightly less efficient, although it's necessary anyway, which is it now doesn't check if sensors exist before running the callbacks on the objects who requested them, which is a very minor issue because 9 times out of 10 all objects will have sensors if they request collisions. But anyway, yes, it uses that dispatcher, it registers with it, and I've added some code to automatically trigger any Python callbacks when an object it receives a collision. So that's how that works. If I press P, you'll see what happens. As soon as it collides with the plane, it prints colliding with plane, and you'll see here I've got the assigning to the variable. You can't assign this to none, so once you've defined it, you have defined it. I'm not really sure why, if you'd really want to set it to none after defining it, so I'm not going to do anything about it for now. But if you want to, then you will need to make some more changes to unregister the controller and so forth, because there's some number counting going on with the collision controllers and so on. The other thing about this is that it always triggers. So as soon as this is touching the plane, this prints multiple times, as you can see. And the callback is simply told about who it's colliding with. It might be the case that you want to know which object actually ran this callback if you want to run the callback for different objects without changing the code. To do that, create an own argument in the callback, and then import partials from functools. Now what you can do is make the callback a partial callback with the own argument predefined. And what this means is when it collides, you'll still have the callback, but you can now write the object which is receiving the collision, own, is colliding with other. And that works like that. Cube is colliding with plane. The only issue about this is that the Blender Python doesn't really particularly like you accessing game objects outside of the main logic loop, which is sort of logical, really. So this is a bit cheating in a way. If you try and do stuff to the game object, it could end up with problems, so be careful. So this leads us on to what you can do with it. 9 times out of 10, you don't want to be told about when a collision is happening. You just want to know whether it is currently colliding or not. Or it might be the case that you only want to act when it starts colliding and stops colliding. The way in which to manage this is to create properties. Now you could assign properties to the game object itself, but that would be tedious, and it also means that it's slightly dependent on the timing. Firstly, because this callback, in terms of processing, is executed in time with the sensors. It doesn't actually guarantee which sensors are called first. So if you try and set a property and then use a property sensor to detect it, it might be the case that it's only detected the next frame. There's no guarantee of the order, so it's best not to use logic bricks with properties that are set from callbacks, unless you really don't mind about the timing. The other thing about this is that you cannot get a callback when it stops colliding because it just stops executing the callback. So the way to do this is to do some polling. So the way I've done it in my example is to open up object collision, and you'll see what I've done is I've created a collision status object. It has an attribute of colliding, and then it has methods to stop it or start it colliding in terms of the register of the property. We have this collision status function which simply initializes the collision status and returns the status object, and then we can then store it on the game object if we so wish without worrying about who's setting it. So let's have it, although just be aware that this own status isn't referring to a Boolean property, it's actually referring to the collision status object. So if I press P and it falls down, you'll see that it says it's colliding. And if I do it again, I'll just check I didn't see a bug there. Yeah. So what this means is that we can check the status independently. So now I can just poll the collision status object. So what you can then do is add something like it'd be like an update function. So after a lot of rejigging, I've finished. So what you do, I've written, is every time we get a collision callback execution, we store the object that is colliding into a set We also check against another set of registered objects that persists between frames to check if we've registered it. If not, we give it an on start callback if we have it. Then we set our collision status to true. Now every frame we call not colliding after the physics has run. In fact, after the rendering has run. And what we do is we look at the colliders that we had the last frame that we processed, and then we say, what's the difference between that one and the one that the collision callbacks have registered? Any difference between the last frame and the current frame will show ones that have stopped colliding. And then we simply iterate through them and tell them that they've stopped colliding if we need to, and then remove them from the register list. We also then set the new colliders, which is what the callback function registers into. We clear it so that it's new every frame, and that way we can always tell the difference between the objects. And then we set our collision status to false, because that way if we don't set it true the next frame, it'll remain false. Another way of doing this would be to use, in fact it's pretty easier to get rid of the colliding attribute entirely and use the registered list. So I could delete these and create a property, define collision, define or just def colliding, and we return bool self.registered, and that way it collides. I'm just going to quickly check why the logic is running so high. I think it's the print statement and the screen recording. So now what we do is you simply say, is the registered list full, or does it have anything in it? And if it is, then we send the boolean value of that, which is yes. So this means you can add this for multiple game objects now. So all you need to do is call a collision status. So you can see how you can build upon this API. I thought that it was too much work to add in all these callbacks, when really all you needed to do was to use it on the Python side of things. So one other thing to be aware of is that I've also added collision masks access, which I already mentioned before. So if you look on here, I have if events w.w key is in the logic.active events of the keyboard, then we set our collision mask to 4. Firstly, be aware that collision groups and masks are bit fields, and so you have to use powers of 2, which is 2 to the 0, which is 1, all the way up down to 2 squared, 2 to the 3, and so on. So here I've used 2 squared, which should put me into my third mask group, and the floor is set to collide with me. It has a mask of 1, which means it'll collide with objects with a group of 1, and has a group of 2, which means it'll collide with objects with a mask of 2. And because my mask is 2 at the moment, and I'll set it to 3, if you like, the third box, that means when I press P, as soon as I press W, it falls through the floor. The nice thing about this is it also interacts happily with the callback system, which goes false. So you can try and change either the group or the mask depending on what you'd like to do, really. And it gives you a lot more control over the game engine. Just one thing to be aware of is I'm not trying to replace the gate logic bricks. They're a very useful system. I'm simply trying to enable more independence from the logic brick system itself, because I believe certain things should be accessible. If they're available to logic bricks, why shouldn't they be available to Python? Especially because a lot of the things that I write, I try to write without using logic bricks because it gives me more flexibility. Because you can always hide behind an abstraction if you like. So that's all for today, and hopefully you guys will try it out. I've posted the patches, but I don't know if I already mentioned, I need to fix one of the patches. I think one of the header files is invalid for the game object collision masks. Besides that, I think all is well, so I shall finish the video here.